Today, my topic is most common failures, because there are a lot of failures we found when we are working on sites. But this is not the time that to give that all the failures that we found, but some of this I like to share with the other engineers. So this is the first picture that you can see this the building collapse in Peta. You can see this white color building. That one also disaster, like, right? So this one also one kind of failure happened 2013, but I have taken this picture, right? With that, the objective is just to share my experience with others. Yeah, this is, you can see this rooftop slab. This is rendered with cement mortar rendered, and this is the top view. You can see there is no water stagnating on top. But if you go underneath of this building, you can see this kind of water patches and the water leakage, right? A lot of things happen, ugly looking, fungus, right? So what are the reasons for this, right? The first reason is actually the negligence of our engineers, design engineers, negligence. We can say like not a mistake. They are not making proper slope when we are doing the rooftop slabs. Still, we can see in most of the project, nobody is doing this slope concrete. I don't know what is the reason. In the construction stage also, they are not making the slope from the parent concrete. But they are doing later on, they are doing some kind of concrete. They call chip concrete. They put chip concrete, right? We are going to discuss it. What is the failure of this chip concrete also? And sometimes waterproof layer they applied on flat surface. You see this left-hand animation picture that I have given, this bad practice and the good practice here. The bad practice, the concrete is parent concrete is not slope, it is flat. Our waterproofing people, what they are doing, they apply waterproof in this flat surface. Then after that, the contractor apply mortar bed on top of this. They are making the mortar bed slope, right? Then what happened? The mortar is like, it is not non-porous material. Always this is porous material. Water can seep through this mortar. So this, what will happen? The water come to this waterproof layer and stagnate somewhere there. When the time comes, time means the waterproof layer, we know that there's some expiry date also, right? Normally they are giving 10 years warranty. But to my experience, before that, this quality will be changed, the properties will be changed, and the stagnant water start to seep through this concrete, right? So this is actually the bad practice. The good practice that we have to do the concrete slope, parent concrete slope. Then there is no any problem. Even though water come to this waterproof layer, there is a possibility to water flow to the gully direction, gully box, right? Even though this waterproof layer expired or this quality change, nothing will happen, because it's still this non-porous concrete is there. Still the water can flow to the gully direction. So this kind of things not happen if the water, this concrete slope at the time of we are doing the rooftop slab. What are the remedies? Design stage that we have to introduce slope concrete initially. In the drawing that we have to mention, right? In the construction stage also, what we have to do, we have to make this slab slope with the parent concrete. Some people I told, yeah, do not make the slope with chip concrete. Earlier I described this one. Most of the contractors, they used to do this thing. They use chip concrete to slope before they are applying the waterproofing. But there's a chance to delaminate this concrete, chip concrete, right? Do not make slope with mortar because it is porous material. We all know that porous material. Then the waterproof, actually, we should not apply on flat surface. We have to make the slope surface only. We have to apply slope concrete only. And the gully box joint also we have to seal properly. Most of the time we found there are some water leakage happen through this joint, right? Rectification method, then we used to do this kind of rectification. Now we have only the flat slab. What we do, we apply some kind of the anchors to the parent concrete and another horizontal sloping mesh. This we can use 2x2 welded mesh. This is galvanized mesh available in the market. So lay the mesh, and now we can do the chip concrete because there is no chance to delaminate because we have already anchored to the parent concrete. Then we can do the balance work, waterproofing and mortar layer, tiling, or whatever it is that you need, you can do later on. Because now we have made this proper slope on this concrete. When we come to this one is upper floor bathrooms, especially upper floor bathrooms. What happened is there's some kind of water leakage due to, initially we can see that water patches only we can see. Later on, the paint will peel off. Then the reinforcement corrosion start, but still we cannot see. It is not possible to see. Then the concrete pieces start to drop, falling off concrete. Then only we can see the reinforcement corrosion. Now the client or the people inside, the people is scared. Now the reinforcement corroded, and now they are looking for solutions. What are the reasons for this? Mainly, the people who do this concreting, they do not properly slope this concrete surface to the gully box. That is the main reason, right? Sometimes initially they have done weak concrete, also a reason, porous concrete. There may be some kind of the cavities inside. Then the other reason is no proper waterproofing done, right? Or time expired. I told you that sometimes after 5 years, the qualities and properties of this waterproofing will change and start water leakage to this waterproofing also. Remedies, as before, what we have to do, we have to make this, we have to remove this old concrete surface, mortar bed, we have to remove totally, and we have to make this concrete slope, right? Then only we can apply our waterproofing. These are the remedies. And rectification. Now there's actually this kind of the corrosion. If we found corrosion like this, first of all we have to check that what is the percentage of the reinforcement corroded, right? Here we have given some kind of standard is if the corrosion area is less than 25%, still we can use this reinforcement. We can do some kind of the corrosion repairs and painting and all that thing. Then we can apply new concrete or something and we can still use the reinforcement if the area, corroded area is less than 25%. If the corroded area is more than 50%, definitely no use of repairing this reinforcement. We have to demolish the slab area and add new rebars and do the new concrete. That is better. Otherwise, you are spending big money and no use finally. Now, this picture I shows, water leakage through this window. You can see this picture, water seeping to the building, right? What is the reason for this? Mainly at the design stage, we have not done proper drop here. Balconies should have a drop, at least 3 inches drop. When we have 3 inches drop, we can use this bottom reinforcement as top reinforcement of the balcony. That is additional benefit we can have by dropping this concrete. Then the construction stage where the people are not making proper slope to outward. This kind of slope should have, but they are not making slope. Finally, what will happen? Water come like this and seep in through this window frame, right? That's what happened to this building. That picture I show you. What is the good practice that we have to do? We have to make proper slope. We have to, first of all, we have to have a drop in the balcony, and we have to make proper slope. And this window should fix in lower position, because most of the time I have seen people are fixing these windows in this level, but no use. You can see that still water, there are possibilities the water can through. This is the good practice, right? So what we can do, so far they have done this. This is the thing, right? The rectification method. Introduce some kind of concrete ledge inside of the window. Then we can stop that water flow. That is the remedy that we can these two pictures shows that formwork and steel arrangement and concrete. And this one, dampness through walls, right? Here I have shown you some kind of a picture. Building is this is external wall. This is actually boundary wall, and inside of the same wall we can see these water patches. How this happen? This water come through this slab, the slab and the beam, and there is a small gap here. Wall between the wall and the beam, water can seep, right? This problem actually we found so many apartment buildings, external walls, they got fungus on the wall. Then finally we found out what are the reasons for this, and we had some kind of rectification method we proposed, and some we have done. This long-term dampness create formation of fungus and fungus on wall, right? So what the reason is, water ingress from this side, and always this joint, the beam and wall joint is always weak. We cannot expect there is a good bonding between the beam and wall, because these two different materials, brick and the concrete, then they are having two different thermal coefficients due to the heat. What is happening is always making a small crack here. Small crack here. The people used to feel that gap with mastic fillers. It is okay temporarily, but what will happen, these properties also change with the time. Then again, this crack appear later on. Then again, the same thing happen. Water will come, right? So, what always this crack is there. We have to expect crack is there, right? So, what are the remedies we can do at the construction stage? So, we can introduce a V groove here at the beam, right? Only the problem is the beam should be a little bit bigger than the wall. That should be a little bit wider. Then only we can provide this kind of V groove or this kind of drip here. At the construction stage, we can do this kind of thing to avoid the water flow coming to the building, right? This is another time that we can do small slope. We can make a small slope underneath of the beam, also possible. Some people we advise to do that. Some people, contractors, they were able to do that, this kind of slope. Then there is no water flow upward. So this wall not getting wet, right? This is another solution if we can do. And what are the rectification methods we can do? It is no use of introducing mastic fillers inside of the building, because externally we cannot approach for this building, either this building or apartment building. It is not possible to approach. So what we can do, we can make this kind of zinc alum flashing and insert through this gap. We have to make this gap and insert the zinc alum sheet flashing. So this is practically we have done a few places. This was success. And dampness through this foundation also possible. Some places we found, you know what happened, this bad practice. You can see we have this plaster, wall plaster first. Later on, we are doing the plinth plaster. Then the what Basuna is doing, they are not making like the overlapping here. They just come and stop here. With the time, what will happen? There is a formation of crack. Then water can through this and come to the building, and building means come to the wall. Then wall always get wet, and there may be a formation of fungus inside of the wall. Good practice, what we have to do, we have to stop this wall plaster somewhere, a little bit upper level, and we have to do the plinth plaster, then insert inside, then we have to complete this wall plaster. Then this water flow, there is no chance to go in. Always this water flow outside. So some places actually we advise people to do, actually by doing this, that was success, and water flow stop, and fungus also we stop. This is another bad practice we are doing most of the project. You can see this picture. This is the balcony. Actually, this is a flower trough, right? Flower trough. You can see the first thing, I don't know, there is some kind of design mistake or construction mistake. I have enlarged this one and given here the picture. There is no reinforcement. This is a concrete beam, but there is no any connection to the main beam. No reinforcement. That's why I have given here the reinforcement not provided. Actually, if they provide reinforcement connection to this main beam, this is not happen, right? This one, this kind of things happen when we are doing the construction. You see this sketch I have given here. They use the upper floor balcony casting time. They use the supports, jack supports. They support to the lower level balcony, and underneath we don't have any support. What will happen? Due to this excess load, there may be a chance to form a crack here, right? Many times we found this kind of things happen, right? So at the construction stage, we have to be very careful of doing this kind of things. We have to provide some kind of props here to avoid happening this kind of failures, right? This is the way that we have done this rectification. We introduce new beam to carry this balcony load. This is the way we have done. Right. Another point that I want to let you know, we used to do this kicker before casting column or walls. We do the kicker. Actually, this is 100 millimeter, maybe 150 millimeter high concrete we cast because we want to confirm this, the grid lines and the locations are perfect. So we want to confirm. That's why we do these kickers, right? And the column formwork or wall formwork, straight away we can fix to the kicker, very easy. But what we are doing, this kicker casting time, this kicker concrete is very small quantity, right? You know, this concrete, if you are going to use a ready mix or something, so we have to order minimum 1 meter cube. Sometimes this all kickers, it will be less than 1 meter cube. So what people do, people use hand mixed concrete, right? Most of the time kicker cast with manual side mixed concrete. Then we cannot expect good quality concrete. You know, these columns are very important, these high-rise buildings, right? That's why we use high-grade concrete for the columns, grade 50, 60 or something like that. But there is no way to achieve this kind of high-grade concrete if we do it side mix, hand mix. That is the main reason. There may be a, many porous concrete we can expect if we are doing side mix, hand mix, right? So finally, what will happen? This will lead steel bar corrosion, right? You see the picture here. I have shown this is in Colombo, 12-story building in Colombo. I don't want to mention the name of the building, but you see exactly this height is 150 millimeter. That is the kicker height. You can see the color difference also, right? This 150 height of the concrete totally very weak. That's what happened here. You can see this reinforcement corroded only that up to that height, 150 millimeter. So due to this weakness of this concrete, okay, this is the way we have done this repair. We had good supports to the beams, slabs, and everywhere we provide supports, and we break the concrete, we remove up to this level, and we do this necessary, the painting of reinforcement bars, and we did grout filling of this area. That is the way that we have done this rectification. And this one, another mistake or negligence, actually we can say negligence. This is post tension beam, right? Actually it's supposed to grout sleeves, supposed to grout, but we found there's no grout. That's what happened. You know, the reinforcement steel bars corroded, right? So we have to make sure that we have done proper grouting when we are doing this kind of precast. And here cracks in beams, shear cracks and bending cracks, flexural cracks. So this is one example, that one case that we found, and we did the rectification of that. These are the cracks, shear cracks, and we rectify these cracks, and with the consultant engineer's advice, we apply this kind of steel plate to transfer these shear loads to the column. And this one is example for the one case for the flexural cracks. You can see this white color one we mark here. These are the crack lines exactly in the middle area of the beam. Right? Then we calculate what are the requirement of this reinforcement and what are the reinforcement they provided originally. Then actually, if we provide an addition 20 millimeter bar to this existing reinforcement, these cracks will not be formed. I mean, that is insufficient reinforcement they provided. At the design stage also, we found that is the mistake done by the design engineer. So rectification is very costly. You know, we have to increase the beam depth and we have to introduce the reinforcement bars, and the difficulty is the concreting of this kind of area. So we have to provide small 50 millimeter dia holes through the slab. Then we happen to cast on top of the slab. Then we happen to increase the beam width and the depth both. Right? So this is another corrosion failure, that only the picture is given here. This one also due to the insufficient clear cover. And these are the some reasons that is, I don't want to proceed with this one. I want to skip. If somebody needs, you can. These are the tests that we have done for this identifying of some properties in concrete. And these are the methods that we can follow for this concreting of, rectification works. Very, this is not very simple one, very difficult and costly also. And these are some other methods. And these are the trowel application of, the grout underneath of the slab soffit, right? After doing all this reinforcement correction, they apply the trowel application to the grout with grout. And these are the some corrosion repairs that we have done. We found this corrosion of this reinforcement, and so we happen to there is no stirrups. All stirrups actually corroded and separated from the main concrete. Right? This is mainly due to the exactly this location. We found bathroom, washrooms. This is commercial building. They had several toilets over there. Due to this water leakage, maybe sometimes 2-3 years, this beam totally damaged. So we did this kind of homework, and we have to use grout. Otherwise, concreting is not possible. Thank you very much. So I hope that you get some kind of information that we can do in our works, our duties in correct manner. So I hope any questions from this side. Thank you.
Thank you very much, Engineer Vijithakumar, for your very detailed presentation with many practical examples from your experience, showing the many commonly occurring construction problems as well as good practice approaches to mitigate them. So we can now take questions. We have one question in the chat, and if any of our participants would like to unmute and ask questions, that is also okay. So the first question in the chat is from Engineer LBA Nandasena. What is the minimum recommended slope to be maintained in a bathroom to avoid issues?
Yeah, we can say straight away that 1:100 is normal practice that we are doing 1:100.
Thank you. Are there any other questions from the audience?
Yeah, Engineer Vijitha, thank you for your very, I mean, you have been sharing your hands-on experience. I have a small question now. This is regarding the rooftop waterproofing. So the general practice is either we use membrane type, torsion type application, no brush applications. So how do you compare these two methods? Well, the torsion type, we know there is a great chance for delamination. But brush application don't have that problem. But comparing the procedures and your experience, which method has given more confidence?
Yeah, as you said that delaminating is a problem. We found some places that delaminated, and due to this delamination, what happened is water passed through this underneath of this membrane, and again leaking starts. So it is advisable to go for that kind of cementitious type rather than going for the torsion type or some kind of membrane.
So do you recommend cementitious type for rooftops where you have a little heat and the thermal expansions are quite significant?
Yeah, still we are covering with some other mortar material also. So there is some kind of protection for that one. Nothing will be happen. I mean, to my experience, I didn't get that kind of problem by applying the cementitious type. So far, I don't know, because I'm not expert on this waterproofing. I want to say what we are applying, the cementitious material we use, nothing happened so far.
Okay, I have another question. This the integral type waterproofing is used for some underground or the water retention structures and all, and even for basements. But the workability issue has cropped up, and sometimes we have faced some problems. Is it a what is your experience using integral type waterproofing? And have you come across any problem by using integral type of waterproofings?
Actually, I don't have any experience on that. Sorry.
Okay, thank you.
Thank you. We have a few more questions from the chat. From Engineer Jay Balasingham. If we use the anti-corrosive paints to the reinforcement bars, there is no proper bonding in between the concrete and reinforcement bars. How do we overcome this issue?
Yeah, we are not using anti-corrosive paints. Actually, we are using corrosion inhibitors like zinc-rich paint available with some suppliers. They actually recommend this kind of paints to this corrosive reinforcement, and they mentioned that there is no any delamination or not proper bonding between the new concrete and the reinforcement. So actually, I have no that kind of bad experience of delaminating this kind of, after applying the paint. Actually, this corrosion inhibitors, actually there is some kind of rough surface, formation of rough surface, not the smooth surface. The anti-corrosive paint is different. Paint is different. We don't recommend to apply paints on this one.
Excuse me.
Yes.
Yeah, regarding this, when the reinforcement are corroded, it says that if it is 25% corroded, then we can go ahead without any replacement of reinforcement. And if it is 50% or more, then we have to replace. Do you have any basis for defining these percentages? Any background or any recommendations given some areas?
Yeah, we found some, specification. I don't have in detail here, but 25% actually is figure is correct, Mr. Krima, because we are considering, when we are doing the designs, we considering a lot of safety factors, 1.4 times, 1.6 times, like that. So ultimately, we can assume at least under service conditions, the reinforcement of 75% is enough, because of we cannot do anything at the moment. We have to maintain the building, we have to rectify the building. So less than 25% area is okay, but this 50%, this is not figured out. But I think rather than going for the repairs, it is cost-wise and long-term activities that it is necessary to break the concrete, demolish the concrete, and do the new concrete that we have to recommend. I mean, 50. We can forget about this 50%. If it is more than 25%, we have to go for new concrete.
New concrete or new reinforcement?
New reinforcement, that means new concrete. Because underneath, if we are going to introduce new reinforcement, it is very difficult to do the reconcrete, because we have to use grout material, and grout material also we have to use pressure pump to do the filling. So it is the costly, that is when we are talking about the cost, ultimately, rather than going for that kind of cost, that kind of grout filling, it is cheaper go for new slab, demolish in that area, this toilet area, only the small area, no, maybe 10 by 10 area. So we can demolish and we can introduce new bars and go for new concrete. That will be cheaper than we are going for grouting from underneath. It is costly.
Right. Okay. Thank you. Another comment regarding this concrete beam and the wall connection. So I have seen that the first three options. The first two options, of course, the architect will not. The most of the time, architects are not allowing that kind of the projections.
Yeah.
And I mean the possible and recommended solution. Sorry, recommended solution is introducing a flashing sheet. That will work actually, but it is also a little bit difficult. I request to think about it a little more and introduce some more practicable and easy solution for that. It is common the mistake and common problem in everywhere actually. Thank you.
Yes, I understood that one, and little bit difficult of this apartment building introducing this flashing, but anyhow we have to have this kind of thing, otherwise we cannot approach outside. So it is very difficult to do any kind of any kind of rectification rather than this one. So still we are looking for some other alternatives, but this one we can do while we are doing the construction also, this flashing.
Yeah.
Right.
Yeah.
This will be
all solutions are okay. I mean, technically acceptable and perfect, but easy, and sometimes there are difficulties with working with the architects and the practical. Practically the slope in the bottom of the beam is a bit difficult, and those are the actually practical issues we are having. Right. Thank you very much.
Okay, so we can go for this flashing. It is
yeah, that's perfect. That's perfect.
Yeah.
Right. Thank you.
Thank you. Another question from the chat from Engineer Prasad. What is the correct post-rectification method for water patches in the ceiling?
water patches on the ceiling. That means we have to expect another few months or few few months. We have to expect that corrosion, spoiling of concrete patches is the dangerous sign. So we have to understand on this, and we have to take some kind of necessary precautions. So first thing that the patches are due to water leakage. Most of the time is on the the bathrooms, under the bathrooms, especially we found, because after 5 years, between 5 to 10 years time, so we can find this kind of thing. That means the time come to do some kind of repairs for the bathrooms, and that means we have to do that I show that slide now, that we have to have some kind of proper slope, and we have to do waterproofing and proper slope with the waterproofing. Then we can do the retiling. Of course, this is sometimes it is a little bit difficult, because after 5 years, every 5 years time that we have to do. But if you do in good manner, good practice, I show you, so we can keep at least 15 years without doing any kind of rectification.
Thank you. The next question is from engineer Vajendra Vijay Vikrama. In the case of blind wall construction, is there any effective way of waterproofing internally rather than using the zinc alum profile?
Yeah, this, if we do waterproofing inside, that everybody knows that is negative pressure action. No? So we cannot stop 100% water seeping through walls. Definitely we have to do something externally. So regarding this internal waterproofing, actually we cannot recommend means this negative pressure acting on this waterproof layer. So we have to do something externally, definitely. Whatever the thing that we have to do externally to protect that the water leaking, water seeping through the wall.
Thank you. Next question from engineer YPK Jayasurya. What should be the detail for the glass wall at perimeter of the building if there aren't any drops?
So we have to make some kind of concrete ledge. I have shown you that any kind of concrete ledge should be there. At the time of we do the construction also we can make if there is no drop. So it is better if we can do, at the time of we are doing this construction.
Thank you. The next question from engineer Chatuska. What are the recommended anchor size and depth for rooftop water ingress rectification? Can we use BRC mesh instead of 2x2 GI mesh?
Yeah, still we can use BRC mesh. And this anchoring, we can do 10 millimeter bar, we can anchor about 1 meter intervals. We can insert into the parent concrete like 75 millimeter is more than enough, because there is small tension coming to this reinforcement. Yes, we want to hold the reinforcement mesh from this delaminating of these concrete layers, because we are casting 2 times. So 75 millimeter embedment depth, about 1 meter intervals.
Thank you. Another question from engineer Komodu. What kind of grout is used in Trowel Application method under slabs where reinforcement is exposed?
Yes, there are some grout in the market which we have to use, grout that we can use upward applications. There are some grout actually we cannot use upward applications, because this is always flowing type. There are some grout available in the market. I can't say the the brand names and everything here, but if you find, you can find this kind of material available in the market.
Thank you, Engineer Vijita. There are no more questions. If there are any further questions from the audience, we can take them now. You can unmute and ask or use the chat box.
So, if I summarize what Engineer Vijita discussed today, it is actually the application of good practices and good detailing practices. So, by using proper detailing practices, I think we can avoid most of the problems. I'm sure Mr. Vijita will agree with me.
Yes.
And also, now the construction sequence in a lot of buildings is we do the structure and then do the walls. But especially when you do residences, especially houses, if you are not very serious about completing structure very fast, the best way is to do the construct the walls and then do the slab. Because if you do the walls and then cast the slab, you'll have a better bonding. So, I mean, if you are doing your houses and all, you always better follow those good sequence. Thank you, Vijita, for your.
Yeah, there is a small comment on that one.
Yeah.
Because I really agree with you on your solution, but the thing is how our people are doing after do this brick wall, they do the beam on top of the brick wall, right? Then what will happen while they are doing this concreting, they are not wetting properly this brick wall. Then finally what happened, this concrete water will absorb by the bricks. Then again we can find weak concrete underneath of the concrete beam. So it will tend to again some kind of corrosion, formation of corrosion of the reinforcement. So that is okay, but we have to advise people and we have to supervise people whether they are doing proper wetting of this one before we do the concrete.
Yeah, I fully agree. I fully agree. So good supervision is also important in that case. Thank you.
Engineer Vijita, one more question from me. That is, I am Engineer Ganesh. This is regarding this waterproofing. Warranty period is 10 years. Maybe it will last 15 years. Then after that, the apartments, many apartments in Colombo, there are many, that means toilets are started to leak, or it is become the reinforcement become to the corrode or something like. Then what is the precaution like? We can take it for the apartment wise for a long time last, because that is all the people are individual know that people are living after 15 or 20 years, they cannot do any this type of correctiveness or whatever thing is their own.
Yes, I also have many the experience on these kind of things happen, and we have to expect after about 10 years time, definitely we have to expect some kind of rectification. So to avoid that kind of thing happen, that's why I said we can keep it at least 15-20 years if we do it initially at the time of construction in proper manner. I mean, with this good practice, we have to maintain good slope, proper slope to the direction of this gully box, and we have to make sure there should be a good waterproofing application, and definitely if there is the waterproof expired, also it will be there if your concrete properly sloped to the gully direction, right? So no need to do the rectification every 5 years, 10 years time if we do in good practice.
But if we don't have any, if we have any external application in time to time, that means after 15 years or 20 years, is there any way to?
No, we cannot recommend. That will be somebody is doing that repairs underneath, or give us some kind of solutions externally, it is not long-lasting one. That's why this we have to analyze in proper manner and do the perfect thing in future. Otherwise, again they will complain.
Thank you. Thank you.
Are there any other questions from our audience?
Shall I just ask few questions? But those are some incidents, but it may not be directly relevant to our topic. I don't know whether it's okay or not. That's
Yeah, you ask.
Yes, actually, I can see there are a lot of buildings when the constructions are going on. They do not get the advisors from engineers. Only just take the design and do. Mainly, I have seen some all buildings. That means the whole building they have done a part and the next part done later, and they connected together. That is one thing. And another thing I saw that they sometimes they use the stirrups of 225 by 300 beam stirrups to 225 by 400 stirrup, making bigger covering. They don't understand about the lever arm. And also I can see there are a lot of structures in our society. That means with the public, they are wasting more money to a lot of reinforcements without getting proper design from a suitable person, qualified person. Can you give any recommendations about those incidents? Anybody else also no problem and engineer?
In my point of view, actually, this is bad habit among our general public. They should understand that we have to make some kind of awareness on that. Now, in our, ISL construction committee also, we are doing some kind of the building clinic program. Also, we found so many people. We understood that they are not aware of this kind of, they have to get engineers assistance when you are doing the design or when you are doing the construction. That's why we try to give this kind of awareness program among our public to avoid this kind of things happen, because they think that without spending some money on engineers for the design and the supervision, I mean, only few bucks they have to spend on engineers, but they are spending a lot of, as you said, they are using, the extra reinforcement, over reinforced, and some other, the oversize. Only the problem is it doesn't matter this, they are using oversizes and over reinforcement, but the thing is, if it is less, is the problem that I show you now. So some cases. So we have to make some kind of awareness among our general public. That is my point of view. I don't know, some others, they have said different views.
Thank you, Engineer Vijita.
Okay, thank you.
Thank you. I think we can close the discussion session. I think it was a very fruitful session. I think we had a lot of good questions answered. So before we bring this question time to a close, on behalf of the Society of Structural Engineers, I would like to thank the resource person for today, Engineer Vijita Kumara, for sharing his very useful, very practical presentation. Also, a huge thank you out to our sponsors for today, Tokyo Cement Group, for continuously supporting the Society of Structural Engineers in our events. Thanks also to the President of the Society of Structural Engineers, Engineer Nandana Abesurya, all executive committee members, and the organizing committee. And finally, I would like to extend our thanks to all the attendees for your active participation. We look forward to welcoming you all back to our next event. Thank you all and good night.
Thank you. Good night.